All right. Last video, the second video, which was supposed to be the last one, kind of chopped off prematurely. So I'm going to, instead of redoing the whole thing, I am going to do example 3, solving by substitution, right here in a third video, really quickly. So example 3, solving by substitution. We got the two equations. Y equals x squared minus 3x minus 2. And y equals negative 3x minus 8. Okay. We've got both equations. The y is already by itself. So I can substitute this expression into the second equation in place of the y. I can just substitute because the y can be replaced with something that it is equal to. So we need to solve this equation. Notice there's only one variable. There's the x. So I'm going to set it equal to 0 by, let me switch colors here really quick. I'm going to set it equal to 0 by adding a 3x to both sides. And I was going to add an 8, but I'm going to hold off on that because notice what's going to happen. The x term is going to disappear, and I just have x squared minus 2 equals negative 8. So if I were to add 2 to both sides, I could solve the simple equation x squared equals negative 6 by doing the square root of both sides. So we'll use that square root property. Remember to do the plus or minus. Now, what do we have? We have x equals plus or minus I times the square root of 6. Now, what that means is that there are no real solutions to that quadratic equation, x squared minus 3x minus 2 equals negative 3x minus 8. So there are no real solutions, which means there are no points on the graph where the two intersect. There are no points where the two graphs intersect. Okay, because when we're graphing, we only work with real numbers for x and real numbers for y. So even though there are solutions to that equation, there are no real solutions, which means there are no intersection points. So there are no solutions to our system because there are no points where the two graphs intersect. And that is it. End of the videos.